In this video, we are going to learn how to prove the formula for the length of an arc. We are going to prove the formula for the area of a sector, the formula for the area of the minor segment, and the formula for the area of the major segment. Okay, so before we can prove any of these formulas here, it is very important that we know the parts of a circle. Okay, so let's say I have this circle here. Okay, so this is my circle here. So we know that the distance around this circle, okay, is referred to as the what? The circumference. Okay, so that's the distance around this circle here. And then this circle here will have a center. So let's say this here is the center of this circle. Okay, so if I have a line, okay, if I have a line that passes through this center and goes to the edge of the circle on either ends, okay, we call that line as the diameter. So for example, if I have this line that is passing through the center, okay, is touching the edge of the circle this side and the edge of this circle that side, we call this line that I've drawn in green as the what? The diameter. Okay, and then what if I have a line that is from one edge of the circle to the other, but it's not passing through the center? Okay, what do we call that line? So for example, if I have a line, okay, from that edge of the center to the other, so we see that this line here is not passing through the center, okay, but it's from one edge of the circle to the other. So we call this line as the chord. Okay, we call that line as the chord, and this chord here, okay, would divide this circle into two parts. Okay, the first part will be this smaller part here. Okay, this smaller part here, that will be the first part of the division. Okay, so we are going to call that first part, okay, as the minor segment. Okay, minor segment. So the smaller part after this chord or this chord divides this circle is called the minor segment, and then this bigger part here, all this part here, okay, all this part here, we are going to call it as the minor what? Segment. So I'm going to write minor segment here. I mean major segment, not minor. Okay, so my major segment, that's what we have there. Okay, so we see that the chord divides the circle into the minor and the what? The major segment. Okay, so what if I have another type of line? Okay, so this is our center here. So let me say we have a line, okay, that moves from this center all the way to one edge of this circle here. Okay, so if you have a line from the center to the edge of a circle, we call that line as the radius. Okay, so I can have another line there from the center to the edge of the circle. We are also calling this line as the what? The radius. Okay, so you can see here that I have this part that has formed, okay, between these two radii lines here. Okay, so between these two radius, okay, this is the first radius, the second radius. Okay, so between those two lines, I have this part here that I'm shading with red dots. Okay, so that part there will be called the sector. Okay, in most cases we just call it as the sector, okay, but others will say that will be the minor sector. Okay, and then this other part, okay, that has remained, if we remove from this circle, we remove only this minor sector, okay, that is formed by this line here and this line here. What are we going to remain with? Okay, so whatever we are going to remain with here, where I'm putting the yellow dots here, okay, all this space here will be called as the major sector. Okay, will be called as the major sector. All right, and then what if we just want a part of this, a portion of the circumference of a circle. Okay, so we know that the circumference of a circle is the entire distance, okay, around this circle here. Okay, so what if we want a portion of that distance? Okay, so let's say we start from here and then we end from there. Okay, and then let me draw this line here in yellow. Okay, so that line that I'm drawing, or that curve that I'm drawing there, okay, in yellow there, it will be called as the arc of the what? Of the circle. Okay, and most times they will ask you to find the arc length. Okay, so they just mean this part here that I've drawn in what? In yellow. That's the arc. Okay, so now we've known all the parts of the circle. Okay, now we can prove those formulas for the length of the arc, the area of the sector, all those things. Okay, so let's prove. So the first one here, they're saying consider a circle C with center O and radius R such that OA is equals to OB and is equals to what? R, where A and B are points on the circumference of the circle C. Okay, so by setting the angle AOB equals to theta, where this theta is between 0 and pi, okay, which is measured in radians, prove that the length of the arc AB is equals to what? R multiplied by theta. Okay, so what are we going to do there? We are going to draw the situation that we've been given. Okay, so here we've been given, we have this circle C. So let's draw a circle C here. Okay, so this is our circle, and then they are saying this circle has a center O. Okay, so if this is the center here, let's label it O. Okay, and then with radius R, okay, such that OA is equals to OB, where A and B are points on the circumference. Okay, so we can say that there we have our point A, and then somewhere there, okay, we have our points what? B. Okay, and then we have this radius that is joining the center to that point. Okay, let me draw it a bit straight from the center to that point, and then we also have the same radius joining to the point B there. So okay, so this is the radius, even this is the radius. Okay, and then this part that is between A and B, okay, we said this part here will just be the what? So this part here will just be the what? The arc. Okay, and that arc we are going to represent its length as L. Okay, we're going to represent the length of this arc here as L. Okay, it has to be a small letter L, so we have a small letter L like that. Okay, so they are asking us to prove that the length of this arc AB, okay, because the arc is starting on A and then it's going to end on B there. No wonder they are saying this arc AB, okay, is equals to R multiplied by what? Theta. Okay, so we know that between these two radius lines here, okay, we are going to have the what? The angle, which is theta. Okay, so we've been told in the question that angle AOB is theta here. So angle AOB. So that's the angle there. So how do we prove this formula that the arc length is equals to R multiplied by what? Theta. Okay, so we are going to prove this formula here. Okay, we are going to prove this formula here by using ratios. Okay, so we are going to get the ratio of this arc length, okay, to the length of the entire circle. Okay, and then we are also going to get the length of the angle that makes this arc. Okay, so this angle here is responsible for making this arc here. So we're going to get that angle divided by the angle of the entire circle there. Okay, so we are going to say arc length, okay, we're going to say arc length divided by the circumference. Okay, so this circumference here is the length of the entire circle, and then we're going to say this is equals to, okay, the angle AOB, which is the angle that is responsible for making this arc. Okay, so I'm going to say angle AOB, and then divided by, okay, the total angle around this center O here, or we can say the total angle of this circle here. So the total angle of this circle, so I'm going to write total angle. Okay, total angle around O. Okay, so this total angle is the same as a complete revolution. Okay, so this is what we are going to do. Okay, you have to know the formula for finding the circumference of a circle, and you have to know the angle that we are going to use there. Okay, so we know that the total angle around the circle is 360 degrees. Okay, but remember I said this question, the angles are being measured in what? In radians. Okay, have been measured in radians. So this 360 in radians is the same as 2 pi. Okay, so this one here is going to be our total angle, and then the circumference of a circle, okay, is found by the formula 2 pi multiplied by the what? The radius. Okay, that's the formula for finding the circumference of the what? Of the circle. So we're going to divide. Okay, so the arc length, we are going to represent it by L. So we're going to say L divided by this circumference of the circle, which is given by that formula. So we are going to say 2 pi r, and then is equals to the angle AOB is what? Theta. So I'm going to write theta there, divided by the total angle around this circle O. Okay, it's just what? 2 pi. So we're going to write 2 pi there. Okay, and then from here we can make this L the subject of a formula. Okay, so let's try to make L the subject of a formula, or you can say you multiply both sides by 2 pi. Okay, that's fine. Okay, so we are going to have L multiplied by 2 pi is equals to theta multiplied by 2 pi r. Okay, so I've done a cross multiplication there, this with this, this with this. So we want to make this L the subject, so we're going to say L is equals to theta, okay, 2 pi r over 2 pi. So what do we see there? We see that the 2 pi is going to disappear. Okay, so the 2 pi is going to cancel with the 2 pi on top. So what are we remaining with there? We are remaining with pi and then multiplied by r, and we know that multiplication is commutative. Okay, so this we can say it's r multiplied by theta. Okay, so this here is our arc length. Okay, so we've proved that the arc length of this AB is given by what? R multiplied by theta, where this r is the radius, and then this theta is the angle between those two radii. Okay, all right, so we are done with the first one. Let's prove the second one. Okay, so the second one, they're saying consider, it's the same question. Okay, so the only different part here is they are saying verify that the area of the sector OAB is given by A is equals to half r squared and then multiplied by what? By theta. So what are we going to do there? Okay, we are going to solve it the same way we did with the first one. Okay, so let's come up with a circle here. Okay, if this is our circle C, then let this be our center. Okay, O, and then from this center O, we are going to the edges of this circle. Let's say there we have A, and then we go to the edge of the circle, we have B. Okay, so we said this area here, okay, or this part here is called as the sector. So we want to prove that its formula for finding the area of this part here, okay, is just given by half r squared theta. Okay, so what are we going to do from there? Okay, we are going to put the angle there that we've been given. Okay, so we've been told that angle AOB is just theta, so this is the angle there. Okay, so let's represent this area here, okay, by A. Okay, so let's say the area here between this A, O and B, okay, is just what? A there. Okay, Okay, so we're representing the area of this part here by A. Alright, so what are we going to do now? Okay, so we are going to use ratios, just like the first question. Okay, so we are going to use ratios. So this ratio will be, okay, the ratio of the area of the sector to the area of the circle is equals to the angle that the angle that is responsible for making that sector to the angle around the center of that circle. Okay, so what am I saying? Okay, so this ratio is going to be the area of the sector that has been formed there, okay, divided by the area of the entire circle. Okay, so area of circle, and then this should be equals to the angle of this sector. Okay, the angle of this sector is just this part, so it will just be angle AOB, okay, divided by the angle or the total angle around this center here. So if we get the total angle around this center like that, okay, that angle in radians will just be 2 pi. Okay, so we're going to say total angle here. Okay, so it means from here we just have to know the area of the circle there, since we have this and we have that. Okay, so what's the formula for the area of the circle? Okay, so we learned in grade 12 that the area of the circle is just given by pi r what squared. Okay, so this is the formula for finding the area of the what of the circle. So where there's the area of the circle, we're going to replace with this. Okay, so I'm going to write that the area of the sector is being represented by A, so I'm just going to write A divided by the area of the circle, which is what, 2 pi r squared, is equals to the angle AOB. Angle AOB is just theta, so we're going to write theta divided by the total angle around that circle, which will just be what, 2 pi. Okay, so our interest is to find the area of the circle. Okay, so we're just going to make that A to be the subject of the what, of the formula. So let's cross multiply there. Okay, so let's cross multiply here. We're going to have A multiplied by 2 pi is equals to theta, okay, multiplied by pi r what squared. So we want to make this A the subject, so we're going to divide 2 pi this side, even on the other side we're going to divide 2 pi. Okay, so it means our area is going to be equals to, so we see that the pi and the pi will cancel. Okay, so what are we remaining with? Theta multiplied by r squared divided by 2. Okay, so I can write that as r squared theta then divided by 2, which is the same as 1 over 2, and then I write my r squared theta. Okay, so we've proved the formula for finding the area of the what? Of the sector. Okay, so that's how you prove the area of the sector. Let's go to the next one. Okay, so the next one here, they're saying deduce that the area of the minor segment on AB, okay, is given by what? This guy here. Okay, so how do we find the area of the minor segment? Okay, how do we find the area of the minor segment? Okay, so let's draw up the circle that we had. So this is our circle here. Okay, and then this is our center. Okay, and then we said from this center we have a radius going to the edge and another radius going to the edge. So this was point B, and then this was point what? A. Then this center here we labeled it as O. Okay, so now here they're saying deduce the area of the minor segment. Okay, so I said for you to have a segment, then you need a chord. Okay, you need a line called a chord. So that line, okay, since it's a minor segment on AB, it's going to come from A and then it's going to go to B. So from A to B there, okay, from A to B there, I'm going to draw a line. Okay, so from A to B I'm going to draw a line like this that goes to B like that. Okay, so this line that I've drawn there is the what? Is the chord. Okay, that line that I've drawn there is the chord. So this is the chord like that. Okay, so this chord here is going to divide now, okay, this circle here into a minor segment and the major segment. So the minor segment will be this part here where I'm putting yellow dots. Okay, that will be our minor segment. So we're going to say this here is our minor segment. Okay, this is our minor segment, and then the rest that will remain where I'm putting the blue dots here, okay, where I'm putting the blue dots here is going to be the what? The major segment. So we're going to label that as the major segment. Okay, so now we want to find the area of this minor segment. Okay, so how can we find the area of the minor segment? Okay, so the area of the minor segment will just be equals to the area of this sector here. Okay, you can see this sector here. Okay, the area of this sector here, let me be showing it maybe in green. So the area of this sector here, this part that I'm drawing in green, okay, the area of that sector, and then we are just going to subtract the area of this triangle that we can see, O to A to B and back to O. Okay, that will be the area of the minor segment. So we are going to say area of the minor segment is just equals to, okay, area of the sector, okay, area of the sector OAB minus area of the triangle, okay, OAB. So you must put a triangle here. So area of the triangle OAB. Okay, so the area of the sector, we are just from finding it. Okay, and what will be the area of the triangle? Okay, so that triangle will be in this form, guys. Okay, and then you have your A there. Okay, so this is your A, and then you have your what? Your B, and then you have your angle there. So how do we find the area of a non-right angled triangle? Okay, how do we find the area of a non-right angled triangle? Okay, so we use this formula. So the area of this non-right angled triangle is just given by area is equals to, okay, half, and then you put the distance that is there multiplied by the distance that is there. But in this case, here we have r, even there we have r. So we are going to say r squared, okay, and then we say sine the angle that is there, which is what? Theta. Okay, so this here will be the area of the triangle that we can see there. Okay, so it means the area of the minor segment, which is this part I've labeled in yellow, is just going to be the area of the sector. Okay, we're just from finding that the area of the sector is half r squared theta minus the area of the triangle, and from finding it here, it will just be given by 1 over 2 r squared sine theta. Okay, so from here we just factorize. Okay, from there we just factorize what is common. So we see that half r squared is common. Then what are we going to remain with in the brackets? We are going to remain with theta minus sine what? Theta. Okay, so this here will be the formula for the what? For the minor segment. Okay, so you can even see here they are saying the area of the minor segment there is given by this. So we've shown it down here. Okay, so what is remaining now is to show the area of the major segment. Okay, alright, so how do we show the area of the major segment? Okay, so it's very simple to show the area of the major segment. We just subtract the area of the entire circle minus the area of the what? The minor segment there. So let me go to the next page. Okay, so here we're being told to show that the corresponding area of the major segment has this formula here. So let's draw the circle that we had there. Okay, so this was the circle, and then we are at the center. Okay, we have so this was the center. Then we had this sector that was being formed here. We had this chord, okay, and then there it was the minor segment. Okay, that was the minor segment there, and it had the area of A is equals to half r squared, and then we had the theta minus sine theta, like that. Okay, all right, so the rest of the circle here, okay, where I'm putting the yellow dot here, okay, this part here will be our major segment. Okay, so how do you find the area of the major segment? You say area is equals to the area of the entire circle. Okay, so the area of the entire circle, so area of circle, and then minus the area of the minor segment, so area of minor segment. Okay, so this is going to be equals to, so what is the area of the circle? Okay, what is the area of the circle there? Alright, so we are going to say pi r squared, that's the area of the circle, and then minus the area of the minor segment, which is 1 over 2 r squared, and then in brackets we are going to have theta minus sine theta. Alright, and then from there we just have to do some factorization. Okay, so we see that the r squared is common here, even there the r squared is common. Okay, so what we are going to do here, we are going to factorize half r squared. Okay, so we are going to say this is equals to, let me factorize the half r squared. Okay, so if I factorize the half r squared from this guy here, what am I going to remain with? I'm going to remain with 2 pi. Okay, so make sure that if you multiply this with this 2 pi, this with this 2 pi here, you are getting back your answer there. Okay, so if I factorize half r squared from this guy here, I'm just going to remain with 2 pi. Okay, and then I'm going to say minus, okay, here when I subtract the half r squared, it means they will just remain a 1 there. Okay, so I'll have theta minus sine theta there, and then I have this other bracket like that. Okay, and then from there we can just multiply what is inside there. So outside we have half r squared, and then we have 2 pi. Okay, so this negative and this theta, I'm going to have minus theta. This negative with this negative, I'm going to have plus sine theta. Okay, so we can see that our formula is shaping up there. So let me create space here on top. Okay, so it means our final area will just be area is equals to 1 over 2 r squared. Okay, and then in the brackets I'm going to have, so let's write it in the way that they want. So I will start with the sine theta, and then I'm going to write plus 2 pi, then minus theta. Okay, so we can see that this here is just the formula for what? The major segment, okay, of the circle. Okay, so that's how we can prove the formulas for the arc length, the area of the segment, okay, the area of the sector, okay, and even the area of this major segment here. Okay, so that's it for this video. Please like, share, and subscribe.